Welcome to Continuing Conversations, a podcast presented by VCU Continuing and Professional Education. I'm Connor Lobb, and on this show, I'll be interviewing different leaders in the field of continuing education. This week, my guest is Dr. Charles Cartin, Director of Makerspaces and Associate Professor of Mechanical and Nuclear Engineering at VCU. We'll be talking about the VCU Makerspaces, how they're useful to students, and what skills students can expect to learn in our Makerspace Training Courses. I hope you enjoy the episode. Okay, I'm here with Dr. Cartin, and I would love to just kick this episode off just by asking you like a little bit about your professional and academic background and how you became involved working with the Makerspaces at the VCU College of Engineering.
Thank you for having me on the show, Connor, or the podcast per se.
The podcast show. The podcast show.
That's fine. I actually have my degrees, bachelor's, master's in mechanical engineering from VCU and also a PhD in engineering from VCU as well. I started in the college in 2003 looking for my education and working my way up to my graduate degrees. And then eventually in 2010, I started working in the department as a collateral instructor in mechanical engineering, and then eventually worked my way up to where I am now as an associate professor and director of the Makerspaces for the College of Engineering within the Department of Mechanical and Nuclear Engineering.
So how did you get, what was the process like for you working your way up to eventually become, was working with the Makerspaces something you had a goal of doing, or did it just kind of like, just sort of the things lined up and that was what you ended up with?
The Makerspaces kind of developed while I was at VCU as a assistant and then associate professor that I am now. So when I was finishing up my PhD and everything, I was working at VCU, and then after I graduated, transitioned over to a community college, J. Sargent Reynolds Community College, and was over there as a assistant professor in engineering and co-program head, where I did a lot of work with the automotive technology department, doing a lot of hands-on programs and stuff over there in electrical course design coupled with engineering. And then eventually I made my way back to VCU and started taking over and doing a lot of the hands-on computer-aided design courses, the physical teaching, undergraduate teaching labs in like solid mechanics, and some of the practicum courses that we started developing in curricula. So I did a lot of the hands-on side of engineering and practical engineering applications. And during the, I would say around the year of 2015, give or take, my time frame could be off, but we started developing courses that did more hands-on prototyping. So I was tasked by my supervisor or department chair to start developing like labs that focused on prototyping, additive manufacturing type processes, and I started building out like the M&E Innovation Lab, which we had started in 2015, and then we kept expanding upon it in 2016, 2017. So we went from probably, I would say 15 or so 3D printers and expanded up to about 40 to 45 somewhere around the end of 2017, and developed a small like support machining shop off from that at the time. And then probably around that time frame, we also had like a small machine shop over in West 107 in the College of Engineering, and we started looking at, with the upper administrators at the time, how to expand on giving more spaces for students to do like practical engineering, hands-on engineering, and starting to work more so on larger projects, because during that time as well, the director of senior design at the time started bringing in a lot of industrial sponsors. So outside companies were bringing a lot of projects for seniors to work on in the College of Engineering. So we needed more space, more tooling, more equipment for students to like build these large scale projects for company sponsors. And then I got pulled into they purchased, the administrators at the College of Engineering, deans and associate deans, purchased they called it Grubb's Garage at the time at 12 West Cary, sorry. So at 12 West Cary, they purchased Grubb's Garage, I want to say around 2017-ish, near that time frame. And I was brought into the mix of that at the time and started working with administrators to set up the renovation process and setting up equipment and relocating our West 107 machine shop down there and expanding on type of equipment we have in there through a grant that the college obtained through Altria. So there was an Altria grant that helped us expand the offerings and the equipment that we had in the facilities. And we opened that in 2019, and we had a Dean Society reception there, and we opened that up. And then probably around that time frame, they had been developing plans for the makerspace in the engineering research building. And they brought me into that, and then started getting me to work more on developing a lot of the makerspace for the college as a whole. And that's kind of what projected me into the position that I'm currently in now.
Nice. That's really interesting to hear about because they're so for listeners who haven't been inside a makerspace, like they're really they're very impressive. There's lots of machinery. It's like there's 3 right on campus.
Yes, we have 3 maker spaces. So we have the M&E Innovation Lab that started out kind of in 2015. And that's probably a lab suite of 3D printing capabilities, digital scanning, and other computational services and computational systems that we actually have in place. And then in 2019, we opened up Maker Garage, roughly a 4,500 square foot plus or minus facility that's traditional machining equipment, mills, lathes, water jet systems, welding capabilities, surface grinders, a lot of sheet metal working equipment. And then I would say during COVID 2020, 2021, we started finishing up ERB Maker Studio and kind of officially got it underway during that time frame. And that's roughly about a 9 to 10,000 square foot facility, give or take, of a advanced 3D printing research lab area with advanced equipment, as also laser cutters and thermoforming and stuff like that. We also have a CNC area in there for programming of G code and CNC type processes that we have staff on site to assist with. Also a small hobby shop in the area, in one of the suites that's like has multiple bench mounted power equipment, different capabilities that we do training in as well. I don't want to say it's small, but I mean, it's let me rephrase that. We have a hobby shop that actually does a lot of woodworking and other type of materials that can be manufactured in that area. And then project storage for a lot of our senior design and collegiate competitions and student organizations accordingly, and project finishing area. We also have a room for sewing and vinyl cutting and various different toolings that students can have access to with appropriate training.
For sewing, like with a needle and thread?
Yes, we have 2 sewing pieces of equipment, two actual sewing machines in the facility, and we have that equipment there for students to use for different projects. We actually had a student using it last week doing some design and costume work, from what I recall.
That's cool. That's awesome. Wow, that's interesting. So I think so the makerspaces are just facilities and large areas you have around campus that are just full of different types of like machining equipment. I'm not going to know all the terms of the different types of equipment, but it's a place where students come to learn how to build things. Could be a way to think about it. And
Yes,
use.
sir. So, I mean, the maker spaces in most people's mind is going to be a space where, for us, engineering students can come collaborate and think about different projects they may be working on, whether it be class related, personal projects, or whatever it may be, related to student orgs. And we have a lot of collaboration, a lot of innovation. The students come in and brainstorm and come up with several different designs, and they test prototypes, and they also come out with final projects that are related to senior design that are very robust. So, I mean, they're there all the time working side by side, and we're actually seeing in the last few weeks a large uptick because we have our senior design expo coming up at the end of April, and a lot of the senior design projects are coming to fruition, and they're wrapping up their builds. And we also have other students working on other projects and other course related or working on projects for course related activities that they're wrapping up before the end of the semester as well. So it's very busy, very busy.
Yeah, I mean, I've been in one while there was a class going on. It's bustling in there. It's very cool. I mean, a lot of people hard at work using the different machines, like learning. It's kind of like a really electric, interesting atmosphere. So, I mean, in terms of students, how are makerspaces valuable to VCU students? I mean, I think you've talked a little bit about that, but do you want to talk a little bit more about like what the real benefit, like in addition to the collaboration aspect and having access to that equipment, there is to students?
So for like our engineering students in the program, we have been providing training modules through OCP. And we've been training students throughout the years on various pieces of equipment. And it actually gives students a hands-on understanding of equipment and machinery that they possibly or will most likely see out in the real world. And also gives them another firm understanding of like uh, tolerances and fits, how things can be actually created on certain pieces of equipment, the capabilities and possibilities and limitations. Because when you're going through any type of education, you do a lot of work in the classroom, a lot of visualization on a computer, but actually having the students come make the physical part and understand how the part's going to come together and how they can actually make it and what the cost would be and the time to make it is an eye-opening experience. So it's taking like theoretical engineering concepts or theoretical concepts in general, coupling it with practical engineering hands-on experience like we do in a lot of our, labs as it is at the College of Engineering. But this is actually letting them see the manufacturing and hands-on side where they're actually physically building the prototype or design that they've conceptualized, and they see, the trials and I guess tribulations that it takes to go from a, thought or a brainstorming type design that they've come up with to get to the final product. And I guess when they're out there later on after they've graduated, whether they go into the real world with a full-time position or go to graduate school or so forth, these skills that they would get through training and using this equipment will actually give them some insight to the individuals they may be working with out like in a manufacturing facility. So they would have a better understanding of what can possibly be done and what could not be done with the type of equipment that may be where they're working or something they may be using later in life.
I mean, that sounds so important for engineering in particular, just because like it's good to be able to know what you can actually do in a field before you enter that field, like practically, like what's possible and what things look like, especially if you're like an engineer who's like constructing um, things. That sounds pretty handy. So not only engineering students can use the makerspace, it's like it's open to more than just engineering students. Is that correct?
So what we're doing is usually we are providing training mainly to College of Engineering students, and also we have the Da Vinci program that uses our facilities for training to take back to their equipment that they have on site. We do try to train people that are interested. But at the end of the day, we've been also very open about this, since it is a College of Engineering resource. We're trying to keep it um, more focused on engineering students per se, but we tend not to turn someone away if they're interested in learning equipment. Um, Meaning if they want to get the training and safety and understand how equipment works, because we've had some students that may have this equipment somewhere else, maybe in private life or something, just want more knowledge of it. So we're giving them an educational experience they can take back to wherever they want to possibly use it, if that makes sense.
Yeah. What a great resource. So what skills, so talking about the training modules, because that's part of College of Engineering and continuing and professional education's partnership around these training modules. We offer training modules for the makerspaces. So what skills will students learn through the training modules that I just mentioned and the workshops offered in partnership with continuing and professional education?
So the first thing that's a utmost priority for us in the makerspace, or any space students may be working in general, whether it be other labs and facilities on campus, it's just our pet peeve is general safety training. So what we have done is, during COVID, we converted our training to be online. So students can take orientation and training that is consistent with understanding the rules and regulations, our safety protocols, and an overview of basic hand and power tool operation that we have online through Canvas. And usually what happens is a student will take the quiz and watch the videos and sign off on the form, and they'll submit a email to EGR makers at vcu.edu. And when they submit that email, it'll be processed on a case-by-case basis, and then they'll be notified if they're allowed to use the facility or not. Majority of the time, they will be granted access, usually if they're related to the College of Engineering. And then when they do that, they have the opportunity to actually go look at more advanced training, which is through OCPE, which is modules 1 through 3, like you've discussed. We also have a training workshop. And after you do the makerspace orientation and general safety training, this opens the door to using general areas in the facility based on your classification, usually engineering students in general. And then you're able to take OCP courses or makers courses, which are module 1 through 3. We also do have various training workshops. Right now, the training workshop we currently have in place with OCP is a 3D printing and laser system workshop. And this is going to give you an insight on how to use basic 3D printing systems related to like fuse deposition modeling, or FDM. And then you'll be introduced in like VLS laser systems that we have on site to actually understand how to cut, engrave, etch, and mark various materials. And you'll be given a project to actually cut out a certain type of name tag while you're on site. Module 1 is our intermediate makerspace training course, and we actually look at basic hand and power tools and bench mounted equipment in this module. So what we look at is we try to reinforce some things that we're not familiar with. Some students are, some users are not, meaning various types of measuring techniques, various type of layout tools, the safe use of hand tools, portable power tools, and bench mounted power tools. So we kind of focus students in the hobby room in Maker Studio, which is room 1318. And we show them the appropriate methods for drilling, sanding, sawing, and in general safety practices that we want all students to follow while using the space. Once students successfully complete that module 1 training, they can move on to module number 2, which the students or users or anyone that's registering for the course needs to be aware that you have to have general safety training and then the modules in order. So they're prerequisites of one another in essence. So if they complete module 1 successfully, they can move forward to module 2. And this is actually where we're going to look at basic fabrication techniques and equipment down at Maker Garage, which is going to introduce students to inspection and measurement methods that are used for metalworking. And also we're going to be looking at more industrial size equipment, such as a larger end drill press, industrial bandsaws, taps and dies, and various belt sanders and metalworking equipment.
Mm.
And this is going to actually bring students further into the safety of that larger end equipment. So we're going to, once again, focus on safety, because each piece of equipment has its own safety protocols that needs to be followed. So they're going to be introduced to even more safety for each piece of equipment. Then they're going to be looking at, in essence, what we do in some of our CAD courses in the engineering curriculum. They're going to be looking at blueprinting and schematic reading, where they're going to understand a drawing and be able to comprehend all the measurements and how to create that drawing. Because usually we give them a schematic at the end to do a specialized project that they have to do to complete the module. And then they're going to be looking at how to do precision measurement with various measuring devices while on site. Of course, it's going to include metalworking with drilling, sawing, and threading operations. They're going to talk about probably cutting procedures, speed and feed, and how to produce a particular part. Usually they're introduced with some type of quiz at the end, and also a project where they would actually be checked off, and tolerances and fits are going to be tested and checked. And usually upon successful completion of that module, students can move on to module 3, which they'll be introduced to manual mill and lathe operation at Maker Garage. And this is going to, in essence, be an introductory module for manual mill and lathe training. So they're going to learn calculations related to those pieces of equipment, and then they'll be given a project to actually replicate from a schematic and make on site. And then staff members on site are going to actually grade and inspect all projects created, whether it be module 1, 2, and 3, and they have to pass with a certain percentage and be within a certain range to successfully pass the program, because we want them to do a good job and understand how to use the tools successfully and appropriately.
After students receive the necessary training, what does access to the makerspaces look like for them?
So what usually happens is when they do the online orientation and safety training, when they email egrmakers@vcu.edu to let us know that they have completed the online orientation, we'll review, and what they're going to be issued is a Makerspace badge. So a Makerspace badge is going to have designations on it, like for module 1, module 2, module 3 training, and we have a color coding system that we put on there upon completion of each module to tell us exactly what level training they have had. And when they come on site in the maker spaces, we have a sign-in system and a swipe-in system. So they have to sign in and sign out, or swipe in and swipe out, a combination of both. And we have part-time or student workers on site, and also certified staff members that actually look at their badge and also review what they're looking for. And students have to be very specific on what they're coming in the space to use. So when a student signs in, we usually ask them, what are you here for? What are you planning on doing? And what's your plan of what you're going to get done while you're here? And then we review our records that we have, both hard copy and electronically, and we let them go into the area that they're certified to be in. Of course, we have oversight where staff members do check in on them while they're working in the certified area they're allowed to be in. The main thing is, even though everyone is trained and certified, we still keep a sharp eye out for safety protocols being followed, and just to be mindful of the students, or I shouldn't say students, just the users' safety at all times, because we just want to make sure everyone remains safe.
Absolutely. So yeah, so they're able, once they get these, complete the trainings, they're able to, provide, they come in, provide a detailed sort of plan of what they want to accomplish on the day, and they're allowed to use the equipment to perform like the tasks they've told you they're going to perform under, you know, guidance and safety of the other qualified people in the space. That's pretty cool. I mean, that's like awesome degree of autonomy for students after they put in that work to take the the modules and the workshops. They're able to, I mean, use the space, which is great.
And just to accompany that comment, the students, like when they do the training, like modules 1 through 3 of the workshop training, usually on the more advanced training, we usually in each one of the modules, we have students actually write out a procedure on how they're going to complete the task that they're going to be working on. So that's the same thing we ask of them once their training is done, is when they come in, it's like, what are you going to do? Can you give us steps on how you're going to do it? So if they're using a particular piece of equipment, we understand, and they also understand how they're going to use the equipment, and we can verify that they're going to do it correctly.
That's fantastic. So safety first, right?
Yes, sir.
So I think, the last thing I kind of want to touch on is just, so we've gone over how these spaces are useful to students, how they can make use of the spaces, what's required of them when they're inside the spaces. But I think like something that's on every college student's mind is like, what am I going to do when I graduate? So like a student who has been certified in using this equipment in the VCU makerspaces and will have knowledge of like similar equipment in the real world. What kind of skills do you see them picking up using the makerspaces at large, and skills they learn in the workshops that'll be useful to them in their careers, be it engineering or otherwise?
So in general, it's like, I just want to throw this in here. It's like when students finish the training modules, we do have the opportunity for the students or individuals being trained to become a makerspace trainer or worker. So we have opportunities for potential employment within the makerspaces while students are going to school at VCU. And a lot of the students that we've had in the past have worked their way up, and it's a good position, and the training is also ideal because it allows students to put these skill sets on their resume. And usually a lot of the skills they learn in the maker spaces. So if we think about measuring devices and precision measurement, schematic layouts and blueprinting and so forth, and just how safety and equipment works, and being able to learn troubleshooting techniques and writing procedures, is a lot of skills they put on their resume. And then I can tell you, several of our students have gone out and been hired in various different positions in manufacturing facilities or other companies. I don't want to get into the details of specific companies, but you know, they've actually, these skills they've learned in some of the work environments they've been in within the maker spaces, and the understanding or the training they've gotten from us has actually assisted in catapulting them in a direction that they're doing their engineering, and also having a lot of the skills they learned in the makerspace being incorporated into the field they've gone into. Because some of our engineering students we've had work for us are more, they want to be in a position that's doing more like hands-on, like CAD work, prototyping, building, stuff like that. So that's where a lot of our students that have worked for us in the past have actually focused on and moved into.
Wow. So I mean, very practical, very useful. That's that's an important thing for students to know when they're sort of determining how they want to spend their time in college. It's like, what am I going to do to make sure that my life post college is going to be successful and happy, and I'm going to be able to have the kind of career I want and be able to do the kind of things that I want to do. So it sounds like maker spaces are kind of really handy for engineering and other students to accomplish that. So that's about all I have for you. Do you have anything you want to add?
Um, Connor, I guess I can say I appreciate you having me on this podcast. I mean, the only thing, I don't really have anything to add besides that we're, open to helping students, giving them a broader education on how to use different pieces of equipment that we have in the makerspace facility. And we look forward to anyone that wants to reach out to us, because we always are willing to help or give them more information that's maybe helpful to them.
That's fantastic. Well, I mean, thanks so much. I mean, you and the team at the College of Engineering are a great bunch of folks and have incredible resources and are clearly, willing to share and help students learn and grow. So, thanks so much for coming on the show.
No, we truly appreciate it, and I hope you have a wonderful day, sir.
You too. Thanks for listening to that episode. I had a great time talking with Charles. And if you want to learn more about the VCU Makerspaces, visit ocpe.vcu.edu/engineering. Thanks for listening.